A wonderful day to all. Welcome back to our General Chemistry 1 class for week 3. And yes, I will still be your teacher, Ma'am Maria Bernadette Esbiazon, for day 2. For this day, you will learn about naming covalent compounds. At the end of the learning episode, you are expected to 1. Name covalent molecular compounds, acids and bases, given their formulas and vice versa. 2. Enumerate some common names of covalent compounds. And 3. Recognize the importance of covalent compounds in daily life. Are you ready? But as usual, we will start with our pretest. Number 1. MgOH2 is a common component of antacids, such as milk of magnesia as well as laxatives. What is the correct name of this compound? A, B, C, or D? Go! 2. Which of the following is the correct name of NH3, a colorless gas with a characteristic pungent smell? A, B, C, or D? Go! 3. Which of the following is the correct Greek prefix for 10 atoms? A, B, C, or D? Go! 4. In naming ternary acids, the anion ite suffix becomes an-blank suffix in the acid. A, B, C, or D? Go! And what compound makes use of the prefix hydro to replace the word hydrogen and modifies the anion's name by adding the suffix ic for its chemical nomenclature? A, B, C, or D? Go! The answers are... What's your score? Don't be upset if you fail to answer some of the questions correctly, because again, you will be learning about these concepts today. Kindly answer now our recap before we proceed to our new lesson. In our last lesson, you have learned the ways of representing covalent compounds using chemical formulas and structural formulas. Can you still recall some of the concepts related to this? 1. Blank compounds often exist as gases, low-boiling liquids, or low-melting solids under normal conditions. 2. The Greek prefix for 7 atoms is blank. 3. Many blank release hydrogen ions or H+, when dissolved in water and they change blue litmus paper to red. 4. Based on the rules of writing chemical formulas for ternary acids, HClO2 must have a name of blank. And 5. The blank of a covalent molecular compound gives the same information as its molecular formula, but also shows how the atoms are connected in the molecule. Here are the answers. It's nice to know that you still remember the lesson about the ways of representing covalent compounds. Let's begin our new lesson. Try making a Venn diagram in your notebook comparing carbon monoxide and carbon dioxide. I'm sure you can do this. Possible answers include and their similarities are... Did you get the same answer? Great! Why is it important to know the difference between carbon monoxide and carbon dioxide? How do the names and formulas help us determine this difference? Because these two gases have different properties. And to name a few, one is poisonous and plants need the other for food making or photosynthesis. The prefixes in the name as well as a subscript in the formula indicate the number of each type of atom. The bonding characteristics of covalent or molecular compounds are different from ionic compounds, since again, they consist solely of discrete neutral molecules that share electrons. And thus, they are named using a different system as well. The charges of cations and anions dictate their ratios in ionic compounds, right? So specifying the names of the ions provides sufficient information to determine chemical formulas. However, because covalent bonding allows for significant variation in the combination ratios of the atoms in a molecule, the names for molecular compounds must explicitly identify these ratios. You've learned in our last video lesson that binary covalent compounds contain only two elements, a nonmetal and another nonmetal. Because of this, they are named using a procedure similar to that used for simple ionic compounds, but prefixes are added as needed to indicate the number of atoms of each kind. The procedure shown in this diagram consists of the following steps. Step 1. Place the elements in their proper order. 1A. The element farthest to the left in the periodic table is usually named first. If both elements are in the same group, the element closer to the bottom of the column is named first. 1B. The second element is named as if it were a monoatomic anion in an ionic compound, even though it is not, with the suffix IDE attached to the root of the element name. Step 2. Identify the number of each type of atom present. 2A. Prefixes derived from Greek stems are used to indicate the number of each type of atom in the molecule. You may refer to Table 1, numerical prefixes for binary covalent compounds found in Self-Learning Module number 7. The prefix mono or 1 is used only when absolutely necessary to avoid confusion, just as the subscript 1 is omitted when writing molecular formulas. 2B. If a molecule contains more than one atom of both elements, then prefixes are used for both. Thus, N2O3 is dinitrogen trioxide. 2C. In some names, the final A or O of the prefix is dropped to avoid awkward pronunciation. Thus, OSO4 is osmium tetroxide rather than osmium tetraoxide. To demonstrate steps 1 and 2A, PCl5 is phosphorus pentachloride. The order of the elements in the name of BRF3, bromine trifluoride, is determined by the fact that bromine lies below fluorine in group 7A. Let's continue. Step 3. Write the name of the compound. 3A. Binary compounds of the elements with oxygen are generally named as element oxide, with prefixes that indicate the number of atoms of each element per molecule. Examples are CO is carbon monoxide, while N2O5 is dinitrogen pentoxide. The only exception is binary compounds of oxygen with fluorine, which are named as oxygen fluorides. The reasons for this convention will become clear in later self-learning modules and video lessons. And last, 3B. Certain compounds are always called by the common names that were assigned before formulas were used. Examples include H2O is water. It's not dihydrogen monoxide. NH3 is ammonia. B2H6, a dimer of BH3, is diborane. Silane and phosphine. For many compounds, the systematic name and the common name are both used frequently, requiring familiarity with both. For example, the systematic name for NO is nitrogen monoxide, but it is much more commonly called nitric oxide. Similarly, N2O is usually called nitrous oxide, commonly known as laughing gas rather than dinitrogen monoxide. Notice that the suffixes IC and OUS are the same ones